system down, you know, say we are a true 40 inches per panel. You have 1 inch for the end clip. You want to give yourself a little bit of room for air on this side. And then we're going to start working from right to left. We work all the way down there. We're not going to cut off our rails on the other end at exactly, say we're doing 3 panels at exactly 123 inches. Because we have, you know, for 124 inches, you have a 1 inch for this end clip. And then in between, you have a 1 inch for a mid clip that holds both this side of this panel down and this side of the next panel.
Yeah, I was more wondering if you left a big enough space that you could walk up between the panels in case you had to get to the second row or chimney.
In, I think California and maybe New York is looking to put on, California already has roofing regulations that need certain clearances, so in case a firefighter has to get on the roof, he's got room to work around the panels and all that stuff if he's got to cut a hole in the roof. But Pennsylvania, no, you can cover your roof, but just think of, you've got to actually install this clip on this side. So if you can get it from a ladder on this side, that's great, but sometimes it's not the best terrain, and yeah. We like to actually leave about a foot around the sides of it as best you can. I mean, it all depends. If you can cover the roof and it's perfect and it looks nice, and you can still get to everything, you know, because if you think about this top side of the roof, if this is the peak here, you can always get to it from the other side. So that's not that big of a deal. But yeah, the sides are nice to leave some room on. We don't have the best, you know, the biggest roof here to work with, so. This is the boring part. I hate more than anything the application process with utility, just because it takes time. You got to fill out this paperwork, and not terrible. There's just certain steps you got to do. Utility interconnection part 1. Basically, whatever your utility name is, you Google interconnection agreement. You need an interconnection agreement with the utility company. They'll usually, PP&L, Penelec, usually they ask for just some basic things. What you want is your the interconnection agreement contract, which is this paper, and with that you see part 1 on the top, 2 pages you got to fill out and sign and send in. It says your name, where it's going, where the actual, you know, or where you live, your name, where the system's actually going, what address it is. Because if you're a part-time resident and you live in New York City, well, they want your main contact information, but they want to know exactly where the system's going to. They want to know the nearest crossing street, they want to know your account number, meter number, energy source. And this is a standard contract for, I believe, all of Pennsylvania. Am I right?
In our experience, we've developed our own.
Okay.
Made it really simple and easy. To my knowledge, every utility has their own, although some of them may have followed the state, you know, guideline or form. So
yeah, you'll see here where it says like electric distribution company. There's a drop-down menu you could choose from a couple different ones. I'm not sure if you guys are on that or not. Current annual energy consumption. You just look at your electric bill and it'll tell you roughly what you did last year and the year before. Inverter type, grid tie, no batteries. Energy source is solar photovoltaic, those are all drop-down menus. Your manufacturer, that comes from the actual inverter itself. The utility company doesn't care about your panels or your racking or how it's attached to the roof. They just care really what is changing it to AC and what is being connected to their system. So they want to know basically a cut sheet on this, and all the information that comes from, comes from about this height down was all the stuff that comes off of this cut sheet. It's a 2-page data sheet that you can get offline. You just type it in, like this is an Enphase 215. You type in Enphase 215 microinverter data sheet, and it'll come up PDF format. And this is all the information you're gonna need. We're at 240 volts for most of us, unless you're a three-phase system. But very, very simply, just kind of transpose it, and if it's asking for total wattage, then you just multiply, you know, the one inverter, which is 0.9 amps, thank you, 0.9 amps times, say we're doing 12 panels with 12 inverters, 0.9 times 12, and then you give them the totals. It's really not too difficult to do the back and forth, but then actually I think I screwed up once on PPNL. Instead of putting kilowatts, I put watts down in the kilowatt section, so according to that paper, I was producing like a megawatt of electricity per year, but they didn't catch it. I don't know if they really care all that much, but, and then you have, I mean, I should say, I don't know if you care all too much, but, well, when I was actually looking through it again, and, you know, you take part one, and then, actually, yeah, let me get to that in a second. And then here you have the customer's signature. You, as a customer, if you're doing it yourself, you want to fill that out and send part one into them, and if you keep scrolling down, this is what you're actually agreeing to. This is all the information as far as disconnecting and who has rights to what and who has this privilege. Pretty standard contract, you really can't change it. I mean, you're at the mercy of hooking up to them. It's not like you're gonna call up and say, well, on page 7, line number 6 of, you know, it is what it is, you're stuck with it. And then at the bottom of that page, or at the bottom of all those pages, is part 2. Part 2 is what you fill out in the installer, if you use a separate electrician to do it, or you use a separate installer, what he fills out, what you sign, he signs, and also the inspector signs. And then you gotta send that back into the utility company, and then wait for them to say you can turn your system on. So overall, production phase basically goes, you figure out you want a system, we order a system in, or we don't have to order it. You figure out that you want a system, you apply, get your permits. I'm sorry, I'm not jumping too fast.
Catching up.
Okay.
And basically, you could apply without having purchased your equipment. You can just use the sheet that you get off, the data sheet you get off the internet to fill out that application.
Correct. Yeah, we don't, for our company, we don't order anything until we get the approval from the utility company saying, yes, you can do it. You know, we want to, not that we've ever had any hang-ups, but we just don't want to order all this stuff and then have, for some stupid reason, you never know why. The one time we actually go ahead and do that, they're going to be like, oh, well, this is wrong, we're not going to let you put it up.
Yeah.
So we just wait till we have our permits, whether it's a township permit, a community permit, and then also the actual approval of the utility company. So
You just have to decide which microprocessor, whatever it's called, microinverter you're going to use.
exactly,
Stuff like
that's the main thing. Microinverters, whatever brand you go with, they're pretty readily available. It's just the panels themselves might not be the exact panels that you originally figured on. Because if it takes a while to get the process through, and then all of a sudden the Hyundai 255 watt panels, there's a big rush on those and they're all gone, you might get stuck with a Hyundai 260 watt panel or a Kyocera or something. But the panel really doesn't matter all that much as long as you just compare the warranties, which again, they're pretty much standard. But yeah, permitting. Check with, if you're in a community, check if you have some sort of community permit. I'm not sure what their rates are and how they adjust things. Usually with communities, we just tell the homeowner, you go get the permit with the community. It's a lot easier because their communities usually, like our office hours are between 8 and 8:15 on Wednesday night, and then that's it. So they're a little bit silly with that, but they're pretty much going to need, I'm sorry, when you apply for your utility company, the interconnection agreement, you're going to need your inverter spec sheet. They're going to want that emailed in, or you could print it and send it in as you know, snail mail. They're going to want that actually part 1 of the application signed and filled out. If there's a fee, I think Penelec is a $100 fee. PPL isn't any fee. They're going to want a site plan. Rough sketch of, if you took a bird's eye view of your property. You know, okay, here's my house, here's the solar panels on my house, here's my utility meter, and here's the disconnect for my system, and my inverters are mounted here, nearest crossing street, and the utility pole. If you do Google that utility name, whatever utility you have, and then the interconnection agreement, they should have examples right there. They'll bring you right to Penelec's website. You click, you go there, and it says, okay, this is a sample site drawing. This is a sample one-line diagram. One-line diagram is very basic, very simple. Just here's your panel, there's your inverter, you know, a whole row of panels, inverters, and then you have a junction from where you go from the roof inside your house, or a junction where you wrap the side of the building with Liquid-Tight, and then you have your auxiliary production meter, a disconnect, and then where you feed into the your electric panel. So, yeah, we'll keep going with.
Blair,
Yes.
I remember somebody got real confused when they looked at this drawing and saw the inverter separate from the panel, that's just for the schematics, it's actually underneath the panel.
Yes, yes. Yeah, this, when you look at your system, and I don't know if you've seen systems around, you're not gonna, all you should see is a little bit of rail on the end and then just panels, and that's it. The inverters aren't mounted like this diagram is just for the, you know, showing the electrical circuit. The inverter itself is gonna be hidden behind the panel, and you're not gonna, shouldn't be able to see it at all. But they're just the 3-line diagram, and that's a little bit, you know, that's a little bit more advanced, but all you really need is, unless you guys take something different, unless you want a 3-line.
No, we just require on the interconnection application, and then line diagram, little site plot of, you know, here's the house, here's the solar array, here's my meter,
Okay.
and it's really pretty simple. There's two other minor pieces of paperwork to sign, but we usually do that the day we go out and interconnect it.
Okay. And you actually personally go out and interconnect it?
Karen and I have 41 solar systems on our system that we've interconnected.
Oh, wow, okay.
We're the ones that do it.
Okay, cool.
And I can't speak for all utilities. I know some utilities are much more difficult to work with.
Yes.
But, you know, the co-op, we work for the co-op up based in Wysice. And we've tried to make the process, when we saw this start to develop, we tried to develop a process that was really quick and easy. Once we get the paperwork, we interconnect within 10 days. So
Wow,
we really try to make it, you know, as pleasant an experience for everybody as possible.
Yeah, we definitely appreciate that.
Do you have any idea what REC does though?
I don't know what Sullivan County REC does.
Exactly from us. I was gonna say probably a fair number of us are with REC, there's nobody here to tell us, so.
Yeah, I would ask for Tom Everlin or Craig Hardy, they probably could give you some, I don't know how many they have or what their process is, but I would imagine they have one, I just don't know.
Yeah, I think that's great. I mean, you guys are the only two that really handle the interconnection paperwork and all that?
Yep,
That's great.
we do all the paperwork. If it's a bigger system, then we go to the engineering department and make sure that it's okay with them, but the vast majority of ours are, you know, the average size for us is about 8 kW, about 8,000 watts. We've got a couple of bigger ones that engineering got involved with, but it's basically right through us, and we turn them around pretty quickly.
Good, I think my first installation was, I think that was Penelec, and that was, after we were done with everything, I sent in the final paperwork, which usually can take 3 days to 3 weeks. Took me 3 months to actually get a word back and calling on the phone and saying, oh, you sent it to that email? Well, why'd you send it to that email? Because that's what it says in the step-by-step process online. Oh, well, you should have sent it to this email, which, how am I supposed to get that? Anyway. But yeah, so definitely frustrations, and there's always like, oh, you know, this person or that person or the other person, but since there's only 2 people to deal with, that's excellent. So yeah, community permit, basically those items you're gonna need for the interconnection agreement, plus some data sheets, just like you have the front and back data sheet, the PDF file for your inverter, you're gonna need one for the solar panel. You're gonna need, I think Unirac has like a 4-page PDF file for their racking. And then also, a lot of times, I just throw it in there too, not that the inspectors, do we have any inspectors here? No? Okay, I mean, last week I said good, but it's actually, I prefer inspectors to be here because a lot of them don't really know what they're looking at. So, being a homeowner, installing your system, you wanna give them as much information as you can, so they're, feel confident that you know what you're doing. So for Unirac and a lot of other manufacturers of racking, they have like engineering, warranties and specs and stuff online that you could just, you know, click on Pennsylvania warranty certificate and just send that with it. That gives them more confidence that you're not just, you know, screwing some pressure treated to your roof and then, yeah, that you know what you're doing and it's a legitimate system, so.
So the engineering reports, you're talking about engineering reports for the racking, not like the load capability of the roof?
Correct, yeah, just an engineering report for, you know, the snow load, the actual load that the system puts on the roof, which is less than 3 pounds per square foot, but you probably wouldn't even get that from the racking itself. Basically, the wind load and the snow load are able to withstand those stresses. So if you're wondering how much this weighs on your roof, it's less than 3 pounds per square foot. So in the grand scheme of like snow and an extra layer of shingles, it's really not that big of a deal. So you apply to the utility company, and in the process of waiting for them, you could also get your community permit, your township permit, if required. But once all that comes back in, everything's approved, that's when we order the system. So you order the equipment, it takes about 2 weeks to come in, usually, and you can get a tractor trailer delivery with a liftgate service. So we just purchased a new shop, I think, a year, 15 months ago. Haven't quite gotten a forklift around yet, so we still get the liftgate service at our shop. And a lot of times they just drop the liftgate service and we slide it right onto our light duty trailer or right in the back of the truck, depending on the size system, and it works quite well that way. So, how do I go actually install this? You'll need ladders to get on your roof, safety harnesses, I don't think I included that on mine. Yeah. He edited my slides for me a little bit. Safety harnesses, we don't personally use them. So, it's a family-owned business, it's me, my father, and my brother, so it's, yeah.
Everybody here from OSHA.
But yeah, is it a good idea? Yeah, we do, when we get on the very, very steep roofs, we do use some harnesses. Chalk line, cordless drill, ratchet, sockets, some electrical hand tools, just some strippers, some linements, pencil, crayon, like these tire crayons that you get, they're great for marking the shingles because you don't have to sharpen your pencil every time you use it on an asphalt shingle roof, and they do make a nice bright line for you. Tape measure, hammer, some pin snips, caulk gun, and a bolt meter. And then other, like when we order a system for you, what we'll get is, I mean, and I say we order it for you, you don't have to order it through us. You can go, if you go online, you can talk with some other different wholesale distributors and tell them exactly what you want. You know, just go through a little, you know, explain it's my first system, I want to make sure I'm getting everything I need. And they're really great about doing that, so you don't have to go directly through us. But
Home Depot has kits, 7th generation, Amazon, there are lots of people that sell kits.
yeah, so, but what we're, you know, if we do get a big amount of people that want to order them, a lot of times we can get a better price on ordering everything at once. So that's up to you. But you will need, in addition to this stuff, you'll need those stainless steel lags. They don't come with the system. Home Depot, we prefer, or not prefer, you need to be at least 2.5 inches into the meat of your roof. You want to be into the roof rafters or the roof trusses. So if you figure on 5/8 for the plywood and the shingle, we figure on, we just say 1 inch. So you need at least a 3-inch lag, so 3 inch, maybe 3.5, 4 inch, whatever you want. Doesn't hurt to go a little bit deeper. But we use 5/16 lags, stainless steel. And the reason stainless steel is because everything that comes in contact with the aluminum, you don't want any type of reaction. So, you don't want just any type of steel washer, you want stainless steel, so nothing reacts and nothing corrodes and breaks down. Roofing caulk and silicone, some, outdoor zip ties, those are the black ones, they say UV resistant on them. They hold up a lot better. Number 6, copper wire. According to electrical code, you need, everything needs to be bonded in number 8 wire. The reason I say number 6 on here is because if you run number 8 wire behind the panel, it's considered concealed by code, which is fine. You could run number 8 wire, but once you break out from, say this is the end of the row here, this is the end of the panel, once you break out from here, it's not considered concealed anymore, and it needs to be able to withstand heavy duty, or I forget how they phrase it in the code book, but it needs to be number 6 if it's run by itself. So we just say instead of buying 8 and 6, buy a spool of number 6, and use that for everything.
Is that your ground wire?
This is my ground wire, yes, sorry. This is the last end, this is actually number 8 because it's the last little bit of it, and we don't use too much of number 8 unless we're doing a swimming pool. But, weatherproof junction boxes. This is all stuff that you can get at Home Depot. You know, if you're doing one row across the roof, and then you get to the end of your trunk cable, you just want to get a weatherproof connector, drill a hole in the side of the box and bring your conductors in there. If you don't want to see the cable, like liquid tight or something wrapped in the side of your building, a lot of times we'll drill the back of the box, put a connector there, and then just run regular 12-3 Romex out the back of the box into the attic, drop it down inside a wall, or a lot of times inside a closet works well too. That way you can hide it and you don't have to see wires coming off your roof. I have a bigger box here because in case you have 2 strings of panels, you want to bring 2 of them into the same box. It gives you a lot more room to work and make your connections. Ground rod, you're going to need an actual ground rod for your system. Yes, you already have a ground rod or 2 for your current electrical system, but what you're going to want is also by code you need your own electric, your own ground to it, which needs, as it comes from the roof, goes down to the ground, your ground rod, it also needs to be bonded to your current electrical system ground. So, and that all needs to be, by code, continuous with, and if you do need to make a splice or a connection, it needs to be an irreversible connection. So if it's a split bolt, you can't just use a split bolt because technically you can reverse that connection and separate the ground. I still don't understand this code because if you want to separate that connection, you just take a pair of linemen and cut it, and then you make the separation. But so you do need a crimper. Some I think it's Greenlee and all those other brands make these crimpers with these big ground barrels, and you just get on there and crimp it, and that's the irreversible connection. 12-3 Romex conduit if you want liquid tight or anything like that, and then a meter base and for your own production meter, because for your system you want to chart your own production. So this is something, again, Home Depot or any electrical store can have this, and then your double 20 circuit breaker for whatever, whether you have a CH or a VR series panel, Square D, anything like that. Whatever panel you have, you want to get that circuit breaker. So,
Does the utility supply the meter?
you guys do. That's the first I've ever heard of that. Yeah, if not, you Hialeah Meter Company. I'm not sure how to spell it. Hialeah, I believe, or something close to that. If you Google it, they sell refurbished meters, and you just get a 100-amp meter from them and plug that in. But this is, yeah, I've never, with utility companies, I've never had them provide anything for you, and I've also never had them actually come out to the site to see it. You know, they reserve in that contract you fill out, they reserve the right to come out and inspect it after you've installed your system before they actually allow you to turn it on. but I've never had anybody actually come out and do that. The only time they come out is to exchange your old meter with a new bidirectional meter. So how do we install our system? I know, Jack has kind of gone over some of the details, I've gone over some of the details, but we haven't really covered everything in depth or in I guess, a consistent manner, 100%. But say you have 10 panels wide, so you're going just one row of 10 panels. You want to find out where that center line is of your system. So if you're trying to center it over the top of a dormer or whatever that is, we like to find center and say, okay, this is exactly where we're starting, and then go and do our calculations to the end. So we have 10 panels, so 5 panels in, we're going to find wherever the center of our roof is, and then we're going to measure 5 panels out to this side with keeping in mind 1-inch mid-clip per panel. So we come all the way out here and say this is the very end of our panel. We like to start our rails a little bit further than that, just so we give ourselves a little room for error. But after you find your center, you come out here and then you put a mark on the roof and say, okay, this is where I want my rails to stop. That's when I'll go ahead and start finding roof rafters. Any roofers here? Anybody do roofs? Yeah, no? Used to? If you're good at it, you can usually find the roof by tapping on the actual asphalt shingles. You can find the rafters that way. If the rafter's here and you hit your hammer, you'll see all the little beads fall down, except for at this point, there won't be any more beads rolling down the roof from this point over. You hit your hammer over here, same thing, except in reverse order. And a lot of times by sound you can find it. A lot of times I say, because sometimes it doesn't work that way. You have to use that method, or they actually have stud finders too for the roof. If you can't actually get access to the roof, you're going to need that. But for all our argument's sake, why don't you just climb up in the attic and trip over those useless Christmas decorations that you never really put up in the lawn anymore, and then find them that way, take some measurements, and at least get close that way. So you want to put your L feet every 48 to 64 inches apart. 48 is ideal. You can go 64, but so if I come out here, I measure it to the end. Okay, this is where I want my panels to start. Then I find my roof rafter, find the closest one, and then say, okay, here it is. Let me pre-drill that one, and then what we like to do actually is take like a 16 penny nail and just drive it into that roof rafter, and then hook a chalk line on that, so that way we can snap a straight line all the way down to the other end. So if you're 16 inches on center or 2 foot on center, again, if you've climbed up in your attic, you know what you are. You drive the nail where you want your first L foot, and then you take your measurements to the other side and figure out what your last L foot's going to be, and then drive the nail there, snap the line, and then on that chalk line you can go back and forth and figure out what the best spacing is. If it's 4 feet all the way, and then maybe the last one's 64 inches. However, that's kind of like a little bit of a do-it-yourselfer thing that you figure out. But so you snap a line that way, and then we also like to snap lines vertical too. We'll find the top rail, and then if we have 3 rows of panels, we'll come down here and find the bottom rail, and where that has to be, and snap a line across the roof too. But I guess the question is, where do we put our rails? You have the panel here, 65 inches. You want to be about 12 to 15 inches down and 12 to 15 inches up. So again, you measure where you want your panels to stop, your rail to stop. You find your roof rafter, and then once you have your roof rafter established, I guess, let me back up. You find where your panel wants to start, and then where you actually want your rails to start, and then from there you figure out, okay, I should have a roof rafter in here from my measurements on the inside of my attic. And then what you do is evaluate what height you want to actually start your rail at before you just start pounding nails in your roof and then snapping lines. So So once you establish the height, then you know exactly where to snap that line across. Because you, okay, I want, if my peak is here, I want to be 6 inches down from my peak, that's where I want my panels to start, and I'm gonna actually, okay, 12 to 15 inches down, I'm gonna evaluate my shingles, and usually, they'll tell you they wanna be within like 1.5 inches or 2 inches of the bottom of a tab of shingles, is where they want your hole to be, and then the rest of the, flash part tucks up underneath. So that's how, you know, if you measure down from where your panel starts and you end up like right dead center of the transition of 2 layers of shingles, well then just bump it up 2 inches. You know, or bump your whole system up 2 inches. And then, so if you're, say 12 inches, say you're 15 inches down, and then you need to be 15 inches up, you just do that measurement, and okay, once you have that top row line snap, and then the bottom row line snap, then you can snap lines vertical, every which one you want, and you have your own little grid system set up on your roof. Makes it a lot easier. Make sure you buy, if you have an old chalk line laying around, buy some extra chalk, because chances are it's out of chalk and you don't. Yeah, and it's a bright color too, especially if you have a dark roof. You know, red and brown don't really go that well together when you're trying to find lines. But, yeah, so your 7/10 of your stainless steel lag, when you actually hold it up and measure that, that's what you want to pre-drill with. You shoot it with silicone, tuck your flash foot up underneath, and then you put your lag bolt down through everything with those washers in between, and that's your output. You could crank down on this thing. I don't have an impact driver with me today, but impact drivers do wonders. I mean, just zip it right down there, tighten it up real good. You actually see this flex up a little bit, that's okay. And as far as your output, if it's a little bit askew from being in line with this rail, that's not a big deal, because when you come back and put the rail on and tighten it down, it'll actually twist it and true it up a little bit. So, pre-drill, stainless steel lag, and just down through with everything. So, install the rails. Let's say we are installing our system. This is the edge of our roof, and we're going from right to left. We like to, and we have 3 rows of panels. We like to establish this end of these rows as square with the roof, so we know that we're all working from the same square side one way. You will get the conditions, sometimes the panels might be just a little bit of a trapezoid looking, not completely square, not completely rectangle. So over the course of the roof, you might get a little bit of shift, or a little bit of what they call sawtooth action. So if you start from one side, you can a lot of times hide that as you get more to the end. But at least, you know, you don't want to work right to left and then the other row work left to right, because then you're not always going to end up correct. But yeah, you put this, align the rails, and then when you put these rails up, they're not going to be exactly what you need. So let the other end run wild, install everything you have, and then the very last thing you do after everything is done, wiring and all that stuff, is then you cut the rails off at the end. Sawzall, cordless Sawzall with a nice metal cutting blade on there. Get a couple of them, because when it cuts through the aluminum, that aluminum gets real hot and actually like binds up your blade, and you'll go through, you know, on say 3 rows of panels, which is actually 6 rows of rails, you might go through 2 or 3 blades, but it does make a nice clean cut and make a nice fast cut. Splice bars. You'll see right here, there's what they call a splice bar. So if you have, the rails come in upward as much as 20 foot long, 240 inches. So if you have something that's more than 7 panels long, you're going to need a splice bar. That's what this is. It just slides right in there. You'll notice there's 4 holes here. You're supposed to have, when you're all said and done, when you're all finished, you're only supposed to fill 2 of these holes. They give you little stainless steel zip screws that zip in there and hold that. And you notice here there's a little bit of a gap too. This is for expansion and contraction. That way these rails can move just a little bit if they heat up or cool down. And also, you only have one side bolt or zip screws in here, so this can flow freely on the other rail. Does that make sense? Like there's, you know, if you put 4 bolts in there, then it wouldn't be able to flow freely. You take 2 out of the one side, and they can move independent of each other. Not that your system's gonna be moving a whole heck of a lot, but you leave that little bit of a gap there, and then you'll notice this bonding jumper here is what bonds the 2 rails together. And there's, I don't have one up here, but yeah, basically here's the video of it. This is an actual bonding lug, which is this guy here. But you'll notice, can you pause that for a second? You'll notice there's this little piece of stainless steel, flat little piece of stainless steel on the bottom, and there's these little circles on it. Those are actually little bars that stick up and down on this piece of stainless steel. It's what they call a weave. That's, I don't know if that's the name of it, weave, W-E-E-V, but somebody's making lots of money and retiring off of this little contraption here. But what that does is, since these rails are anodized aluminum, it's like a thick coating to them, you need to make a good electrical connection to them. Everything, as Jack was saying, everything metal on your roof needs to be bonded together and run to ground. So these weaves, for this is one for the panel, you clip it in here, you tighten your panel down, and this weave bites down into the panel and also bites up into the panel and down into the rail at the same time, and it makes a good continuous bond through all your metal components. That's all this thing is here too. It has a weave on the bottom of it that bites down into the rail, this little metal flapper piece. This bolt rides in the rail itself, and then as you crank down, this nut tightens on the bolt and compresses the weave, makes that connection, and then this here is actually meant for the copper ground wire to go in there, and you crank down that 7/16 and tighten that up.
Larry, do you bond rail to rail all the way down the roof?
Yes, that's a good question. Everything needs to be bonded together, everything metal. The best way I can describe it is when lightning is looking down on the earth and looking for the best thing to, most attractive thing to attach itself to, if it sees your roof covered in solar panels, it's basically like saying, screaming, hit me, hit me, hit me. Well, you don't, if you put $20,000 on your roof, you don't want that. So what this does is makes everything bonded together, run to your own ground rod, run to the existing system's ground rod, so that way, when it looks over the roof, it sees all this metal, but it just looks as appealing as everything around it because it's all rounded, and it looks basically just like an open field. Does that make sense? It's not. It basically makes it not as appealing to strike your roof, or any more appealing than your roof already would be. But for these rails, you have these weaves, these little bond things go underneath the splices. So here you have a splice bar, same little weaves go underneath these things that join rail to rail on the horizontal. You have weaves that can go underneath the tab of this inverter, so that bonds the inverter to the rail. So not only do you have inverter bonded to the rail and rail bonded to rail, then you also have weave bonding the panel to the rail also. And you have one weave per corner per seam of panels. So if I have a panel here, my next panel is going there, I just need one weave in between this seam of panels, whether it's top or bottom. And what you need to do is, okay, if I'm running 10 panels across, this first panel is established here, I put a weave here on the lower rail, next panel goes on. Mid-clip, next panel goes on. I come over here to the other side of the second panel, and I put my weave on the top rail. And then between panel 3 and 4, I'll go on the bottom rail, top rail, bottom rail. You alternate that because you need to make everything bonded together. And then that little piece of copper wire that we had coming up here, that's supposed to run from each rail down and connect. You can do every rail if you want, it doesn't hurt, but you really only need to do every other rail. Because if I have this rail, if I bond, say this rail, skip this one and hit the one below it, skip the next one, hit the one below it, I don't need to bond this rail because this rail, this lower rail is already bonded through the panel on the zigzag action. So yes, everything does have to be bonded together, but technically by code, you only have to bond every other rail if you alternate your weaves. But for the electrical inspector, especially if he doesn't know what he's looking at, if he sees the bright shiny copper wire and he sees every rail bonded, that makes him feel really good, like, you know, your system's very safe, so he doesn't have to worry about it. Yeah, so that, any questions on the bonding part of it? Yes, sorry.
How was the splice bonded? Because you said one side was left loose.
One side's left loose so the rail can free flow, but this braided stainless steel piece here, yeah, as we've done, so that way it can expand and contract. And there, I mean, you don't have to bond these inverters with the rail with the weave. They have actually a little bond screw on them that you can run on copper wire, which we do sometimes, depending, like in New York State, they're very, very strict with their money. They give out a lot of money on the state level, and they have inspectors that'll do a spot inspection every so often if you're approved contractor. So they look for everything. I mean, I had one guy write me up on an installation because the main electrical panel didn't have all 6 screws holding it on. And it's like, that wasn't, you know, the electrical system's 20 years old. When you're here to evaluate the solar, yeah, I interconnected it correctly, but if it's missing 1 screw, I mean, how many times, anyway. So what we do is we go over, you know, we go overboard with our bonding and everything, so that way they don't have to catch you on anything, because it's just a pain. And we run bond wire through every inverter and up every rail and everything, so that way they can see it and look up there and say, oh yeah, that's a really good system, okay, good, I approve. So your inverter trunk cable. You want to, here's your trunk cable, like we said, you mount your inverters. What do we have here? That's inverters. Yeah, so once you have your rails up and established, you have that one side you want to start with and run everything. You'll have that side established true. You have, you want to come through and get ready to start mounting your actual inverter. So there's just like the same little nut and bolt setup that's on the little bonding lug that's going around. The same thing that holds that bonding jumper together is the same size nut and bolt that hold the inverters to the rail. So they just slide right inside this top rail. You want to slide all them in. You don't have to mount your inverters yet, but you slide all them in because once you know, if I have an inverter going here, let's say, and say I have another splice going here, and if I tighten down, crank down on this and crank down on that, then I can't get my bolts in there to mount my inverter. So you'll learn that the hard way probably. You know, we still make that mistake sometimes. But another little thing about these weaves is once you crank down on those, and they pierce the aluminum on the bottom, they pierce the aluminum on the top, you're not supposed to use those over again if you have to move this. If you have to adjust this or slide it one way or another. If this is affected by the panel, where a panel seam is, you're not supposed to use those over again because as you compress it, yeah, it bites in, but it also loses its effectiveness by cranking down on it like that. But so once you've established where your inverter goes, how do we establish where our inverter goes? Under the panel. Yeah.
About 20 inches.
Roughly, yeah, exactly. 20 inches away. You have 40 inches for your panel. And on the back of these panels, which I have the other panel on the truck, there's a little module box that the 2 wires come out of. So we like to actually, like if this is, say this is here, 20 inches from the next panel, we like to offset it a little bit, so that way that module box and the wires coming out of it doesn't get all screwed up with our actual inverter. But on this end, say we decide we're gonna put, our junction box on that end and go through the roof on that end. Well, on this end, we just can't leave raw wire. Well, this will have its own little termination kit that's all weatherproof and cranks down on it, and it'll probably take you 20 minutes to do the first one, but after you've done one, you're an expert, and you can do it with insane efficiency next. But you strap up your trunk line and just go all the way down until you come to your junction box. Again, zip ties, don't be afraid to get a couple bags of those, because sometimes your zip tie will be right here where you need to put your mid clip, and it'll be right in your way, and it'll be kind of a pain. Zip tie, and yes, nothing touches the roof. So basically, after what we like to do is, okay, we know where our panels are going, then we measure and actually put an X on this upper rail. We don't have to put an X on the lower rail because there's no inverter going there. The panels, the connections are on the upper side of the panel, so we put our inverters on the upper side of the rail. And it makes it nice too, is if, as you're using this as a ladder, you could walk on this rail, you could lean on this rail, you're not worried about stepping all over your inverter. But we'll measure the back side of the rail, and then we'll put an X where every inverter needs to go. So that way we know where to slide our bolts to, and then they're roughly there. We can crank down on our inverter, tighten them up 100%. And what you want to do, the reason why you zip tie it is one, by code, you don't want any of the wires rubbing against the roof. That'll wear them away, and then you'll have open conductors. And two, it doesn't look nice. I mean, when you stand back and look up your roof, you want to just be able to see the rail, maybe a little bit of a swale and wires every now and then, but you really don't want to see any wires at all. It looks a lot nicer.
Hey Blair?
Yes.
If you're installing multiple rows on your roof, if the inverters mounts on the top rail, does that mean you start with your lowest row and install them and keep working your way up? Or
What we do is, we'll start with the lower rail and work up if it's a difficult roof to walk. And then we'll start with our top row and work down, because it's that top row you really want to get lined up with your peak.
okay.
And when you line it up with your peak, that is really like you're going to take a lot of time establishing your first row of panels, because that's really what you're going to base the rest of the system on. So you don't want to start low and then work high, and all of a sudden, your peak is straight, and then you end up with your panels going at an angle, and you don't realize that until you're in your third row. But yeah, and you could evaluate. Keep in mind that you put your panels right up tight to the peak, and you take your measurements right off the peak. Well, you're going to be able to see that from the back side of your house, because you have your output, then you have your rail, and then you have your panel on top of that. So you probably need to be at least about a foot down from your peak on one side in order to hide it from the other side, depending on your elevation and on your deck or your lawn or whatever it is.
Is the trunk cable, can that not be exposed to sunlight? Is that why you run that into a junction box and then take Romex from there?
No, that can be exposed to sunlight. That's meant to go on your roof and be exposed to sunlight.
Okay.
It's just, this stuff is pre-manufactured cable that's, I think, $25 or $30 per 40 inches.
Okay, so it's more expensive than Romex.
Yeah. So what you'll do is, say you want to put 15 panels on a row, or on your roof, and you have a row of 7 and a row of 8, or a row of 8 and a row of 7. Well, how do you connect all those two? Because if you get to the end of your row and then run down here, your wires might not be able to connect. So instead of ordering 15, a continuous length of 15 of this, you might order 16, just so you have an extra spare piece to jump to the next row of panels. And this is actually a ground mount system that we did. And you can see here the bonding wire. This was one in New York State, so we ran the bonding wire through everything. 2 bolts holding it in. You can see an L-foot there on the rail, and the grounding wire comes right along here. Nice close up there. And then you can see here, pause it for a second. You can see this is a black zip tie holding everything on. You have the bonding wire coming along, and instead of using this type of bonding jumper, we just use all those bonding lugs. And again, we just ran, since we're running copper wire along the whole system for the inverters anyway, we just kept that copper wire going. New York State, they won't ask questions if they see a lot of copper. And then it comes through, and we just tighten it down. Crank down on that, and you can see this, yeah, this is going over a splice bar right here with a little bit of a gap to it. And then here's also the trunk cable, if you can see that faintly with another zip tie holding that in too. Okay.
This might be a good time to just take closing questions.
Yeah, this is, I mean, we're throwing a lot of information at you. This is kind of the night of one, to be bored a little bit with the paperwork and say, I don't want to deal with that. To kind of separate, like, yes, I want to do it myself, or no, I don't want to do it at all, or maybe I want to get a professional to do it. But this is so you know, it's a do-it-yourself, but it is involved. The actual installation process probably takes, for a 15-panel system, maybe a day to do. And you're gonna
Maybe this is a good point to ask Pete, since Pete's
Yes.
done a system or two. Want to say a few words about what it's, you're learning?
Well, yes, I was involved with the training Blair went through, and we had a house, and it was the first house that they used for training house. So I got a solar system out of it, but I had to pay for a system, but the installation was done through learning, and then I, since then, installed 2 more systems, one in my cabin and another one at home. And it's, if you follow what Blair said, it's very simple. You have to get your rails up and get them lined up, and then everything sort of fits into place. When I installed, I put a ground mount in. And that's a lot easier because you're working off the ground. You can get underneath it and you can check things and make sure that the wire's all zip tied up there and everything. So, but it does take a little bit of thinking and laying out and figuring out what you're gonna do next so that you don't get ahead of yourself.